So chapter 8 is about quantities in chemical reactions. And I skipped the first section. I can't remember why, but I'm pretty sure there was a decent reason. So this is section 8.2. Making pancakes. So hopefully everybody has eaten today and you're not starving, because otherwise we might make you hungry talking about pancakes. This chapter is about something called stoichiometry. So there's a big new word for you. That is the numerical relationship between chemical quantities in the chemical equation. So we're going to talk about the mass of something that reacts with the mass of something else and what mass of product. So we can predict amounts of products based on the amounts of reactants that are involved. This type of calculation is a central part of chemistry. This is super important. And we're going to talk about pancakes because, like with many other math-related things, if we talk about something we're familiar with first, it's easier to understand the concept. Once we understand the concept, then we'll translate that to things we're not so familiar with. So, a chemical equation is a little bit like a recipe in cooking. You take this much of this and this much of that and you put it together and you'll get so many cupcakes or pancakes or whatever. The recipe gives us numerical relationships. So here is a simplified recipe for pancakes. I don't recommend using this recipe at home because it's missing some things, but it'll serve our purposes. And here we even have pictures. 1 cup of flour, 2 eggs, half a teaspoon of baking powder, and of course you have to mix those together and cook them and stuff, and then you'll get 5 pancakes. Okay? So that's the relationship. It's a recipe. We can write it here like it was a chemical equation. 1 cup of flour plus 2 eggs plus a train whistle plus half a teaspoon of baking powder will yield 5 pancakes and a headache. That train. Okay. So when we're looking at this, if we have 2 eggs and enough of everything else, we can make 5 pancakes. And we can express this as a ratio. I know, I'm ruining pancakes for some of you. I'm turning pancakes into math. I'm sorry. But from this recipe or this equation, for every 2 eggs, we can make 5 pancakes. So 2 eggs to 5 pancakes is our ratio. We can also write that as a fraction. I have a friend who teaches middle school math. She says that fraction is the F word to her students. Fractions. So. But we can write that as a fraction also. 2 eggs to 5 pancakes. Does that look like a conversion factor? Yeah, it does. Well, what if we had 8 eggs? How many pancakes could we make? $20. How'd you do that? You did math in your head is how you did that. Let me show you what went on in your head, whether you realize it or not. Well, there's 5 pancakes for every 2 eggs. If we have 8 eggs, 5 pancakes per 2 eggs, that gives us 20 pancakes. You can do that in your head when you understand the relationships very well. It's harder when we get to moles of oxygen and moles of methane or something. Then it doesn't make any sense to you, and you can't do it in your head. So we have to learn how to write it down, and this is the primary reason I want you to learn dimensional analysis, is because it works so beautifully here. So we had 8 eggs. We wanted to know how many pancakes. This ratio or this conversion factor comes from our recipe, from our balanced chemical equation. we get 5 pancakes for every 2 eggs. That is a relationship between pancakes and eggs. It only works for this recipe. It's not going to work for some other recipe, but it works for this one. If we have 8 eggs, we can get 20 pancakes. Any questions?